Hello guys, now we will be going on our next project, which is the smart radar scanning system. Okay, so it is hard to detect the objects in the blind spots or the unmanned areas. So human monitoring isn't possible in all the directions in every time. So we need to build a automatic radar like object detection system which detects the object and it should alert with the distance, at what distance the object is present. Okay, the challenges is limited visibility and the uh, no constant monitoring. The goal of the system is to increase situational awareness through the automation. So what are our requirements? It should scan 180-degree and real time. It should alert at real time, and it should be affordable, and it should be easy to build. Next, what are the possibilities to build these type of systems? One, we need ultrasonic sensor in order to calculate the distance, and the servo to rotate to monitor 180-degree rotation, and the OLED to display the distance and the object present. So next, what are the components we need to use to build this type of system? One is the Arduino Uno, which is the microcontroller for our system, and next is the ultrasonic sensor used to calculate the distance. Next is the SD90 servo motor used to rotate and monitor from 180-degree rotation. Next is the OLED display to display the angle as well as the distance. Next, we need some jumper wires to make the connections, and the breadboard to connect the system effectively, and it is most organized way to connect the system to the breadboard for the prototype version. Next, we need the USB cable to upload the code to the Arduino Uno. Next is the Arduino Uno, which is the microcontroller for our project. These pins are the digital pins, like a digital component needs to be connected here, and we have another two pins, SCL and SDA. These pins are used to connect the OLED display. Next, here we have the analog pins, which is used to connect the analog devices, and here we have the power circuits for external power usage. Next, here we have one silver port, which is used to upload the code to the microcontroller via our system. Next is the ultrasonic sensor. It is used to measure the distance of an object. One is the trigger pin, and next is the echo pin, which is the receiver, and this one is the transmitter. It will transmit the waves, and this will receive the waves which are echoed back from that object. Here we have four pins. One is the VCC ground, and next is the trigger and echo. Trigger is the output pin, and echo is the input pin. Next we have the OLED display. In OLED we are using the 1.3-inch OLED. Here we have four pins for ground, VCC, SCL and SCA. SCL is the serial clock pin. SDA is the serial data line pin. This uses I2C communication. This uses I2C communication, to which we have to use wire.h library, for I2C communication. Next is the servo motor, which has three pins. One is the ground, VCC and signal. The orange pin is the signal pin, red pin is the VCC, and the brown is the ground pin. For any system to be built, we need to have one circuit diagram which tells about the connections of that system. Here we will look into our circuit diagram. See, one is the Arduino Uno, which is our microcontroller, and next is the OLED display. The SDA pin of OLED should be connected to SDA of Arduino Uno. Likewise, SCL pin to SCL pin, ground to ground, and VCC of OLED must be connected to 5 volt of Arduino Uno. Next, we need to connect this servo motor. Servo motor is the servo motor VCC pin should be connected to 5 volt of Arduino Uno, ground to ground, and signal pin of servo motor should be connected to D12 of Arduino Uno. Next, we will move with ultrasonic sensor. Ultrasonic sensors trigger pin is connected to D10 and echo pin is connected to D11, ground to ground of Arduino Uno, and VCC of ultrasonic sensor to 5 volt, or it can be connected to 3.3 volt. Next, how it is working like our system. The servo motor rotates from 0 to 180 and it will continuously rotation from 0 to 180 and 180 to 0. It will be continuously rotating. Next, ultrasonic sensor measures distance at each and every angle of servo motor. The OLED display is used to uh, show the angle and the distance. Whenever the object is detected, it will show one dot, and otherwise it will show some line indicating there is no object in that path. Next, we will go with our code. This is the code for radar system. As I said, we are using the servo motor. We will be using servo.h library. Next, for as we are using OLED display which uses U8G2 library, so we need to include this library into our system. Next, wire.h is used for I2C communication. I2C communication. Next, for any calculations, we will be using math.h library. This line is basically used for initializing the OLED display. Next, we will connect the trigger and echo pin. The ultrasonic sensor trigger pin is connected to 10 and echo pin to 11. Next, servo motor pin is connected to 12. We need to create one object from the servo.h library, which is my servo. Next, we will be creating two variables to store the ultrasonic sensor data. One is the duration and one is the distance. As we know, distance is calculated by speed into time. Next, we will be creating another angle, which is the minimum angle is 0 and maximum angle is 0. Maximum angle is 180 degree. These range is used to rotate the servo motor in this range only. Sorry. Next, we need to take one variable called some readings, which is used for average reading. We will take one value for the averaging of readings. Next, we will take the radius of the OLED. As we have noted, it has 64 rows, so we'll be leaving some space at the bottom by 12 rows, so it will be remained by 52 rows. Next, in the void setup, we need to attach the servo pin, and we will be declaring the trigger pin as output, echo pin as input. This line is to set up the OLED. Next, in the void loop, we will be writing the for we will be using the for loop to rotate the servo motor from minimum angle. The minimum angle is 0 and the maximum angle is 180 degree, and in between those it should be increased by 5, and if after increasing by 5 value, the servo motor should be rotated. To that we have another function called as my servo dot write. Next, to calculate the distance, we will take one distance variable. Next, we will be writing one function called get average distance. In the get average distance, we will be saying that total distance is 0, and to get the averaged value, we will be using this line. Likewise, it is rotated from 0 to 180. Likewise, it should be rotate from 180 to 0 degree. Here we have get distance function, which is used to get the distance from the ultrasonic. Here we need to clear the trigger pin. That's why we are writing digital write low for microseconds, 2 microseconds. Next we will be transmitting the waves via trigger pin. So we are writing trigger pin high. It should be high for 10 microseconds. After that it should be low. It should be converted to 0. Next, for duration calculation, we are having the pulse in function, which is used to take the input from the echo pin. Next is we are returning one value, which is the duration into 0.034 divided by 2, which is used to convert to centimeter value. Next, this is the display radar function used to display the readings in the radar. Here we are clearing the previous display. If any mistakes is present, it should clear the previous display. Next is the function called draw radar background. It is used to draw the radar layout. Next we need to create the x and y coordinates from the object point. So we are using x and y variables, which has the calculations as you can see in the code. Next we will draw one line, bottom line at 64 row and the 64 minus 12. As we saw above, we are leaving some space at the bottom. Here you can see that it 64 minus 12, it is used for leaving the space at the bottom. Next we will be setting the font in order to print the angle and the distance in the OLED display. Next we have the radar drop background. For background we are drawing one circle to detect one object. If the object is detected, it should draw one dot. So this is the code for your smart radar system. Let's check with the connections and check the output.
Hello everyone. Today we will be doing a project which is named as Smart Radar. So let's start with the putting the components in the breadboard. So here is the OLED. So let's put the OLED in the breadboard, and second one is the ultrasonic sensor, and here is the servo motor. So let's start the connection. Here the OLED uses I2C communication, so the ACL of the pin should be connected to the ACL of the pin of the Arduino Uno, and SDA of the OLED will be connected to the SDA of the Arduino Uno. So for OLED it works on the VCC of 5 volt. So let's connect the VCC 5 volt to the OLED of VCC, and first let's take the ground terminal common, and also the 3.3 volt. Then connect the ground terminal to the ground of the OLED. So this OLED connection is completed. So next is ultrasonic connection. So let's connect the ultrasonic sensor to the Arduino. Here in the ultrasonic sensor there will be 4 pins: VCC, ground, trigger and echo. So the VCC will be connected to the 3.3 volt, and trigger pin of the ultrasonic sensor will be connected to the D10 of the Arduino Uno, and echo pin of the ultrasonic sensor will be connected to the D11, means 11th pin of the Arduino Uno, and the last is which is a ground pin will be connected to the ground terminal, which we have taken common in the breadboard. So let's start with the next connection, which is a servo motor. Here you can see a 3 color of wires in the servo motor. The orange one is the signal wire, and the red one is the VCC, and the brown one is the ground. So let's start the connection. Here orange, which is a signal pin that is connected to the D12 of the Arduino Uno, and VCC, it works on the VCC like 5 volt. So let's connect to the 5 volt, and ground to the ground terminal of the Arduino. So after connection of this, let's connect with the computer. So let's connect the Arduino to the PC. As you can see the output here in the OLED, you can see the angle plus distance. Has that any obstacle comes in nearby ultrasonic, it shows the distance. After removing any, you can show the line that is in the OLED. The point that means is an obstacle which is in front. If none, it shows a line. As you can see here, if no one is there, then it shows a pure line. If some obstacle comes near it, it shows an round dot. So as you are learning AutoCAD, so you should design a model like the ultrasonic should be attached upon the servo motor. So make design like that ultrasonic that plays up to the servo motor. So as you are learning AutoCAD, so make a design that as a ultrasonic holder, so it can place above the servo motor, so it can easily rotate with the servo motor.